the next single linked list problem that we will try to understand and solve is find the intersection of two linked lists. So the problem statement says that you are given the heads of two single linked lists, namely head A and head B. Return the node at which these two single linked lists intersect. If the two linked lists have no intersection at all, return null. So the problem statement says that we have gotten two single linked lists, namely in head A and another single linked list in head B, and both of them will basically get merged at a point, basically get intersected at a point. Ultimately we need to find that intersection point and we need to return the node at which those two single linked lists are intersecting. If at all, if there is no intersection, then we can return null. In the case of Python, we will return none. Okay, so that is the problem statement that we have gotten. Let's take the first example that we have gotten here and let's try to understand what exactly the problem statement means when it says intersecting at a point. So the first single linked list here that we have gotten is 1, 2, 3, 4 and 5. Here the second single linked list is 6, 7, 8 and after that it is 3. That means after 8 it is connecting to the 3 of the first singly linked list. That means that intersection is happening at node with the value 3. So the output should return node with the value 3. Okay. Similarly, if you take the second single linked list, here the single linked list has value 1, 2, 3, 4, 5 and second single linked list is 6, 7, 8, 9, 10. If you see, there is no common intersection point. That's the reason why we don't see any value that we have gotten here in this single linked list. As a result, we will return null here. In the case of Python, we will return none. If we take the third single linked list here, 1, 2, 3, 4, 5 and second single linked list also 1, 2, 3, 4, 5. That means that the first node itself is intersecting. So output should return head with the value 1. Okay. If you take the second example here, fifth example here, 1, 2, 3, 4, 5 and the second single linked list is 2, 3, 4, 5. That means the second single linked list is nothing but the sub linked list of the first linked list. That means that intersection is happening at 2. So the output should be 2. If you see, you should get the better understanding of at first example what it means to be intersecting at a point. Basically, whatever the first common value that you find in both the single linked list, that is where the intersection is happening. Okay, so that is what the problem statement that we have gotten. After looking into this problem statement, right, if we can find a node, the first node which is common between two single linked lists, we are good. That is the point at which the intersection is happening. So we need to find the first common node out of the two singly linked lists. So for that, obviously we can take the help of a hash map, right? With that we will be able to solve it. So here two single linked lists that we have gotten are like what you see on the screen. If you see, if we represent that in the pictorial representation, they will look like this. So here the first single linked list is very straightforward and second single linked list first value is -1 and next value is -2 and the third value is nothing but 2. This is where the first common occurrence is happening. So we can say the intersection is happening at 2. Now using the hash map approach, according to our algorithm, we need to find the first basically duplicate node. Okay, that is common in the two single linked list. Duplicate, or what you can say is common node in two single linked list, then that is the intersection point. For that we will be building a hash map. This hash map is nothing but a key value pair, right? So here in the key we will store the entire node reference value. It is completely up to you. You can store some boolean flag or you can store some integer. It is completely up to you. We are not bothered about the value that we are storing here. We will only take the help of the reference of the node itself. So first what I will do is I will start iterating over the first hash map completely and I will put all the node references into the hash map. So here if I iterate first single linked list, I will put the node reference of the complete node reference. I'll put the entire node object and boolean value. Let's just assume that I'm putting true. I'll move on to the next node. So 2 also I will put true and move on to the next node. 10 will get added. Then 3 will get added and 4 will get added and then 7 will get added onto the hash map. So this is the hash map that we have constructed after iterating over the very first singly linked list. Now what I will do is I will start iterating over the second singly linked list. So here the first value is -1. -1 is present inside this hash map. There is no complete node reference of -1 inside this hash map. So we will move on to the next node. 2 is present in the hash map. 2 is -2, sorry, here we have -2, right? So node with the complete reference -2 is present in this hash map? No. So immediately we will move on to the next node where we go to 2. If you see, as part of the first single linked list traversal, we have put the complete node reference of 2 in the hash map. Since we have reached the same node here, we have the complete node reference. So we have found the first common node that is common between these two single linked lists. That means that the intersection is happening at the node with the value 2, and we can return that node with the value back to the user. Okay, so this is a simple hash map based solution, but the problem here is we will end up consuming order of n units of memory if at all, if the first single linked list has n nodes, because first of all we have to construct that hash map, then only we will be able to check the second singly linked list nodes available in that hash map or not. So the space complexity will become order of n, even though the time complexity will be constant, which is order of n itself. Now, how we will solve this problem effectively? With the help of a simple iterative approach. So that is where a simple iterative approach with a simple twist in the iteration process comes into the picture. That process we will discuss right now. Now let's see how can we use a improved iterative process for finding the node at which the intersection is happening. So here what I will do is I will parallelly traverse both singly linked lists. That means first I will take help of one variable called first node or something. It will be pointing to the head node of the first singly linked list. Similarly, I will take another variable called second pointer. It will be pointing to the head node of the singly linked list. Now immediately what I will do is, as long as this first pointer and second pointer are not same, I will keep on moving them to the next nodes. So here I will move the first node by first pointer. As long as first pointer is not equal to second pointer, then we will keep on moving to the next node. So here first pointer is pointing to -1 and first pointer is pointing to the node with the value 1 and second pointer is pointing to the node with the value -1. Both the node references are not same. So what we will do? We will simply move on to the next node. So second node will move to the node with the value -2, and here first node will move with the value 2. Now again what I will do? First pointer has a value of 2 and second pointer has a value of -2. Both of them not equal. So what will happen? First pointer will move to the next node and second pointer will move to the next node, which is nothing but 2. Again both of them will get compared. -10 is not equal to 2. So what will happen? First pointer will move on to the next node and second pointer will also move to the next node. Here first node has a value of 3 and second node has a value of -10. So both of them are not equal. We'll move the first pointer to next node and second pointer to the next node. Again 4 is not equal to 3. What will happen? First pointer has moved to the next node and second pointer also moved to the next node. Here first pointer and second pointer pointing to 7 and 4. Both of them are not equal. Remember that even though you are seeing the numbers on the screen, remember that we are comparing the complete node references. Remember that is an important point, because if we are simply relying on comparing the values, there is a chance that there might be duplicates in the single linked list. So whatever the process that we are writing will not work. that means even though you are seeing the numbers here, we are comparing the complete object of that node's references. Okay. Anyway, here 7 is not equal to 4. But here at this point of time, first pointer has reached the end of the first singly linked list, because this first pointer is pointing to the first singly linked list, right? And it has reached the end. That means once it reaches the end of the singly linked list, we will move this first pointer to the beginning of the second singly linked list. If at all the second singly linked list pointer reaches the end, then we will point it to the first singly linked list head node. Since it has reached the end, let me change the pen color to orange, and it will point to the head node of the second singly linked list, which is nothing but -1. Again, what will happen? We have moved this first pointer to the last node, and second pointer also will get moved to the next node here. And here first node has a value of -1 and second node has a value of 7. Both of them are not equal. So what should happen? First pointer should move on to the next node. So it will point to the -2. Immediately here second pointer has reached the end of the second singly linked list. In that case, what we will do? We will move it to the head node of the first singly linked list. So it will come to the head of the first singly linked list. Again we will compare. -2 is not equal to 1. What we will do? We will move to the next. So here first pointer will point to the node with the value 2, and second pointer will get moved on to the next node and it will come here. At this point of time, if you see, both second pointer and first pointer are pointing to the same node. So 2 is equal to 2. So the object reference will match and we can no longer compare, because both of them are pointing to the same node. That is the reason why the intersection is nothing but we have that intersection at node with the value 2. Okay, so that is the simple iterative process that we will be following. Simple, we will take the first pointer pointing to the head of the first singly linked list, that means head A, and another pointer, it will point to the head of the second singly linked list, which is nothing but head B. As long as this first pointer is not equal to second pointer, we will simply update both of them to the next. But at any given point of time, if they are already pointing to the tail node, what we will do? We will move that to the other singly linked list head node. By doing so, at a point, both of them will meet at the same node. That node is nothing but the intersection node of the two singly linked list. By updating that to the other singly linked list, what we are doing? We are making it traverse equal number of times. As a result, both of them will meet at the same point, and that will be nothing but the intersection point. So that is the math behind it. Okay, very simple example. Now, if let's just assume that what we will do, let me just take another example. 1, 2, 3 and 4. Let me take another example. -1, -2, -3 and 4. And after that, let's assume that we have 5. Now here, according to our algorithm, first what we will do? First pointer will point to the 1, second pointer will point to -1. Both of them are not equal. Then what we will do? We will move both of them to the next, and 2 and -2, which are not equal, so both of them will move to the next. And here, both of them are not equal, so both of them will move to the next. Okay, at this point of time, both have pointing to the same node, which is nothing but 4. So the intersection point is nothing but 4. Here we were able to reach this node in the same iteration without moving either first pointer or second pointer to the other singly linked list head, because both the singly linked list have the same length. If at all the two singly linked lists have different length, then we will see a case of where we have to move one of the pointer to the other singly linked list head node and continue the iteration till they meet at the same point. Okay, so that is the process that we will be following. Let me quickly go ahead and write the pseudocode of this specific. So here what we will do, we will write one function called intersection of two linked list. They will take head A and head B, or head 1, head 2. It's completely up to you what variables you take both the single linked list. Immediately what we will do, we will define one variable called first node or second node or current node 1, current node 2. Variable names are completely up to us. Let's just name them as current node 1, which will be used for keeping track of the first single linked list. Similarly, current node 2, what will happen, will represent the second single linked list. Immediately what we will do, as long as both this current node 1 is not equal to current node 2, see here we are comparing the both objects. That means the references will basically get compared. In this process, at any point of time, if this current node 1 is equal to null, or in the case of Python we compare it with none. If this is the case, what we need to do, we need to update it to the second singly linked list head node, because in the iteration process we have reached the end. That means that it should go ahead and point to the second singly linked list head. So cn1 is equal to head B. If this is not the case, then what we will do, we have not yet reached the end, we will simply move on to the next node, cn1 equal to cn1 dot next. Along with that, this is the first single linked list. Similarly, we need to do the same thing for the second single linked list also, right? If cn2 is equal to null or none, then what we need to do, we need to move it to the first single linked list head node, which is nothing but head A. And if this is not the case, then we will simply move on to the next node. So cn2 equal to cn2 dot next. Okay, once this while loop gets completed, both of them will point to the same node. If at all, if there is any intersection, if not, anyway we are going to the next node, both of them will reach the end. In that case, we will not have any intersection point. Both of them will be pointing to the null or none in that case also. So it's completely up to us whether we want to return cn1 or cn2, as they will point to the same node. Okay, so that is the pseudocode. The time complexity will be obviously order of n in this, and the space complexity will be constant, which is order of 1. Okay, you see, whatever the hash map approach which consumed order of n units of memory, we have eliminated that by simply using a trick in the iteration process. The trick is nothing but, once we reach the end of the singly linked list, we will update that variable with the other singly linked list head node, so that in the iteration process they will meet at the same point. Okay, so that is the algorithm behind this finding intersection point according to the singly linked list. Now based on this, I want to give you another improvement that you can do, but the problem statement there would be, we will be given two sorted singly linked lists which are intersected at a point. Now your aim is to find the intersection point and return that specific node. So based on this additional property of two linked lists that we have gotten is sorted singly linked list, and we have already seen how do we merge the two sorted singly linked list, right? So based on that, see if you can find a algorithm for finding the intersection point effectively. Even though in that case also you can deploy the same algorithm, that will also work absolutely fine, but you can take the algorithm that we have already used in the merging of two sorted singly linked list, and you can find the solution even effectively. Okay, that problem I will leave it to you to implement and check out. If at all, if you are not able to, you can reach out to me. I'll write the solution for that as well. Now let's write the JavaScript code for getting the intersection node between the two singly linked lists. So here I have added a new class for that, and I've added a new function which is basically taking the head 1 and head 2. Now our aim is to find the node at which these two linked lists are intersecting. So according to the logic that we have discussed, what we will do, we will basically define couple of variables. Current node 1, this will be pointing to the current node that we are processing on first singly linked list at this point of time. Similarly, let's just define another variable, current node 2. This will be pointing to the current node that we are processing from the second singly linked list. Now we will run a loop as long as this current node 1 is not equal to current node 2. Here what we will do, if at all this current node 1 has become null, that basically means that we have reached the end of the singly linked list 1. To continue the logic, what we will do, if at all if the current node 1 is null, we will update it back to the second linked list head node such that the logic will keep going on, right? So here let's just check that. If at all this current node 1 is equal to null, in this case let's just update current node 1 back to the head 2 of the singly linked list. If this is not the case, what we will do, the current node 1 we will simply be updating it to the next. So current node 1 is equal to current node 1 dot next. Okay, and this is from the perspective of the current node 1, which is holding the reference of the list node that we are processing from the singly linked list 1 at a particular point of time. If it is null, we are updating it back to the second singly linked list head node. Similarly, we need to do the same thing for second singly linked list as well. That means that current node 2, if it is equal to null, that means that we have reached the second singly linked list end. In this case, whatever the current node 2 we have, we will update it with head 1 of the singly linked list. Head node of the first singly linked list. If this is not the case, we will simply update current node 2 is equal to current node 2 dot next. Okay, when we were discussing the algorithm, I have clearly explained why we are following this approach, so that I will not be repeating here once again anyway. In the end, once this current node 1 and current node 2 match, that basically represents that that is the intersection node. Here we can simply return either current node 1 or current node 2 because both of them will be pointing to the same node, right? So it really doesn't matter what node we are returning. Okay, so here I'm returning current node 1. Okay, so that is the simplest logic for checking and getting the node at which the two linked lists are basically intersecting. Okay, now let's just call this. Here I have created the object of the singly linked list by importing it, and I have added 5 values onto this list. Similarly, I have created another singly linked list object and I have added 3 values onto this list now. Here, let me just remove this and explain this line of code. If you see SLL2 dot tail, which is nothing but this 8's next, technically at this line number 36 is null, but here what I have done is to that next I have assigned the SLL1 get of second index. That means this 3 I am adding. That means both the lists are intersecting at this value 3. So if I run this code right now, the output that I am expecting is 3. So let's just run this code and see. We are returning the node right here. Ultimately, we are not returning the value. We are returning the complete singly linked list node object itself. That is the reason why here we have printed the same thing. See, the node that we have written has the value 3 only. Okay. If at all, if you want to just print the value, you can do that as well. It is completely up to you. We've got 3. Okay. So anyway, just remove this dot value because we will be checking a non-intersecting list as well. Now if you see, I have commented out this intersecting code, right? Basically the code which is adding the intersection between the two lists. Now there is no intersection. So if I run this now, the output should be null. So if you see, the output that we have got is null. Here, instead of this, to establish the intersection, what I have done is from the first singly linked list, I'm assigning the node at the index 0 itself. That means this 8 is connecting to the node 1 itself. That means both lists are intersecting at 1. So if I run this now, the output that I'm expecting is node with the value 1, and that is what I've got on the console. Okay, so whatever the logic that we have written for checking and getting the intersection between the two singly linked lists is working absolutely fine, and that's it for this solution. I'll see you in the next problem.